Hey everybody. So I want to talk quickly about what a standard deviation is and what a variance is. So a very popular topic in statistics is standard deviation and variance. So I just want to identify how they are taken care of, how do you calculate them, and then what exactly do they do? What is their purpose and why do we have them? So why I'm talking about both is standard deviation and variance is if you have variance, usually standard deviation is not far behind. They kind of go hand in hand. Because if you have one of those answers, like if you know the standard deviation, that means in turn you know the variance, and vice versa. So if you know the variance, then you can definitely get the standard deviation. So first off, formula-wise, on the AP formula sheet, you have two formulas on there, or maybe it's just the top one, I don't remember. But they talk about the sample variance and the sample standard deviation. So if you're given a sample set of data, you could calculate that sample's variance as well as that sample's standard deviation. So I'm really quickly going to talk about how you calculate these, and then I'll tell you, all right, here's the difference of the two and why we use them. So sample variance is represented by S squared. Just for the sake of argument, if you had a population standard deviation, that's sigma squared, and a population standard deviation, that's just sigma, okay? But we're dealing with samples. So if you have a sample variance, S squared, it's going to be represented by this formula, which is 1 divided by n minus 1. N is just the number of data points that you have. And then you have the summation of xi minus x bar squared, okay? So what's happening here in this formula is you're going to take every single individual data point and subtract the mean and then square it, okay? So take a data point, subtract the mean, square it. Set that to the side. Go to the next data point. Subtract the mean, square it, set that to the side. Subtract the mean, square it, set that to the side. And then you're going to add all of those calculations up. Once you have all those calculations up, you can multiply by 1 divided by n minus 1, or just divide by n minus 1. And that is your sample variance. Now, I mentioned that variance and standard deviation go hand in hand because variance is represented as s squared, and sample standard deviation is represented as s. If you notice, the formula is exactly the same except there's a square root there. So if you want to go from a variance to a standard deviation, you just need to take the square root of the variance and you'll end up with a standard deviation. If you want to go from the standard deviation to a variance, you just square it, square the formula here, square this side as well. You're going to end up with s squared. So let's talk about what is the purpose of a variance and a standard deviation. What they're going to help us do is they're going to help us talk about spread, how spread out a data set is. It depends on the context of the problem and the numbers you're dealing with, but if you have a very small standard deviation or variance in comparison to the data set that you're dealing with, that means things are very compact. There's not much spread there. Whereas if you have a large standard deviation or variance, that means things are very spread out. Okay, so if you had test scores in a class and the standard deviation was, we're talking about percentages from 0 to 100%, all over the scores on the test. If you had a 2% standard deviation, that's relatively small when scores can range from 0 to 100. Whereas if the standard deviation was like 8, 9, or 10, that's pretty big. So a smaller standard deviation means the data is pretty compact together, very tight spread. Where if you have large standard deviations, that means things are very spread out, okay? So it's definitely going to help us talk about spread, and it's going to help us do several other things in statistics, which we'll get to in a later topic. So why do we see both, okay? The proof is kind of in the formula. So if I had a data set on the amount of money, whatever, I collected a sample on the amount of money people earn in a week, whatever. If I calculated the variance, notice how you square your calculations here. So for the variance in this situation, you would end up with dollars squared as your units. Now that's pretty tough to kind of conceive and be like, oh, the spread is $17 squared. Well, I don't know what a dollar squared is, so talking about the spread being $17, a variance of $17 squared, that's pretty tough for me to conceptualize. Whereas if you go from the variance and take the square root and go down to a standard deviation, you could talk about the standard deviation in this made-up example as just dollars. So the standard deviation is $4.15 or whatever. That's a lot more willing to work with and be like, oh, I know what $4.50 represents. That's much easier to work with than dollars squared. So that's why you'll see these kind of go hand in hand. But the one we more deal with is a standard deviation. Okay, standard deviation is what we're going to use when we talk about spread, and it's going to allow us to do several things in the future. So there's a quick overview on just standard deviation and variance.